Hi everyone. In today's video, we will know about AWS EKS, means Elastic Kubernetes Service. What is Elastic Kubernetes Service? Why it's important? What are the uses? So basically, Elastic Kubernetes Service is a managed control plane. It's provisioning and maintaining. It does not manage the worker node. It's a self-managed node, and also Kubernetes worker process must be installed. kubectl and kubeproxy also, and also it's a managed the node groups and run EKS optimized images, automatic processing and lifecycle management. So let's see one by one. So in this video we will learn what is Elastic Kubernetes Service and why it's important, what are the key features, and what is deployment services and health, and the architecture and how it does work, and what are the use cases and advantages and disadvantages. So lastly we will see the demo also. So first go to the theory part. What is AWS Elastic Kubernetes Services? So it's a fully managed services that you can use to run the Kubernetes on Amazon Web Services. So EKS is a fully managed services. It helps to run the Kubernetes in the AWS. And it's a open source software that enables you to install and manage the application at high scale. So it's open source, we can easily use. And it's automatically handles the key infrastructure tasks such as scaling, updating, and ensuring the high availability of the Kubernetes control plan. So it automatically handles the task infrastructure. So it includes in scaling and updating. So these are all automatically handled by Elastic Kubernetes Services, and it's a highly availability. So the next is why it's important. Why it's important means it's automatically handle the Kubernetes services, and it's a highly secure, and it's a scalability and high availability, and also it's securing and integration with other AWS services, and it's a scaling and backup. Here we see AWS Elastic Kubernetes Services is preferred choice for managing the Kubernetes because it eliminates the complexity of setting up and maintaining Kubernetes control plans, so ensuring a highly available and secure environment. So it's managing the Kubernetes. Why? Because so it eliminates the complexity of setting up and maintaining the Kubernetes in control plan. So that's why it managing the Kubernetes, and also it's high availability and secure environment. And I've already told that Kubernetes is it's integrate with other AWS services like SC. It integrates seamlessly with AWS services like IAM for authentication, VPC for networking, and CloudWatch for monitoring, and providing a robust ecosystem for your applications. So other AWS services are IAM. So IAM for authentication means it provides the access key and security key in the users. When we are creating users, it provides access key and security key. So it provides the authentications, and VPC, so virtual private cloud. So here networking, we can use the protocols and TCP, UDP, it's networking, and CloudWatch for monitoring, and also it providing the robust economic system for your applications. So that's all the important things. So why we use the EKS instead of anything. So these are all the main important points. So the next thing is key features of AWS EKS. So the main key features are its managed Kubernetes control plan, and it's a native Kubernetes compatibility, EKS managed node groups, so security and compliance, and hybrid and multi-cloud support. SC one by one. Managed the Kubernetes control plan. AWS automatically applies the latest patches and updates to the control plan, keeping it secure and up to date with the latest Kubernetes versions. So it contains all the details up to date with current version also, and it automatically applies. So no need to manually we need to update or anything. So it's automatically applied to the latest patch and the latest Kubernetes version. So the control plane is distributed across multiple availability zones, so that application should be highly available to us. So it's available for the multiple availability zones. We can easily highly available for everyone. The next is native Kubernetes compatibility. So it integrating with EKS with any Kubernetes native tools such as kubectl, Helm, and more easily. EKS run upstream Kubernetes where user can move their workload from other Kubernetes environment with a minimal friction. So it integration with any Kubernetes native tools that has kubectl and kubeproxy and Helm and more easily, and EKS, and also EKS run upstream the Kubernetes where you can move their workload from other Kubernetes environment easily. The next is EKS managed node groups. So it run EKS optimized images and automatic provisioning and lifecycle management in the node group, and it updated and security patches keeping your worker nodes secure without manual intervention, and can automatically scale the number of worker nodes in response to application demands. So ensuring you have the right amount of compute power of all times. The next is security and compliance. IAM roles feature allows Kubernetes service accounts to assume the specific IAM role, giving you fine-grained permission for your Kubernetes workloads. So security means I've already told that IAM provide the authentication for creating the access key and security key. Kubernetes accounts to assume specific IAM roles, so it's gained the permission for your Kubernetes workloads. So it provides the security. So when we are trying to access it, asking the permissions, so we can give the security key, then only we can access. The next is hybrid and multi-cloud support. EKS can be deployed across different regions and used in combination with other cloud providers for a true multi-cloud strategy, and can use EKS on AWS Outpost to bring native AWS services to put your on-premises environment. So multi-cloud support means it provides multiple different regions deployed, and also it's provide the other cloud providers for the multi-cloud strategy. We can use the EKS or on AWS, and also bring some native AWS services also we can use in the on-premises environment. These are all the key feature of AWS EKS. The next is deployment. So what is deployment? What are the key features? So let's see. Deployment in Kubernetes is a declarative way to manage the state of your application pods. It provides robust automation for scaling, updating, and self-healing. It's manage your application, and also it's a robust automatic for scaling update. The key features are declarative updates, rolling updates, rollback, scaling, and self-healing. So declarative update means it decides state in YAML file. It ensures your application matches it. So coming to the rolling update, it's update the pods gradually to prevent downtime. So in the declarative updates, it's desired in the YAML file. So we are writing some script using the YAML file. So it decides state in this YAML file, and it ensures your application matches it. So rolling update means it updates pods gradually to prevent the downtime. The next is rollback. Rollback means is revert to previous version if something goes wrong. Previous version if something goes wrong. The next is scaling. So scaling means is easily scale pods up or down based on the load. So scales up down based on the load we are using. The next is self-healing. It automatically replaces failed or unhealthy pods. So in this EKS we don't need to do any manually, so it automatically do itself. So when something or replaces failed or unhealthy pods are using, it automatically replaces the pods. The next is services. A service in Kubernetes is an abstraction that defines how to expose and access a set of pods, providing a stable way to connect to them regardless of their changing IP addresses. So it's an abstraction. Service is an abstraction. We can it defines how we can expose or access the set of pods, and also how to connect, way to the connect of the providing stables, and regardless for changing the IP address. So in the service it helps to how to connect and how it works, the way we are using the IP addresses. The key features are stable networking, selector mechanism, and load balancing. So stable networking, it provides the consistent IP or DNS for accessing the pods. In selector mechanism, routes traffic to pods matching the specific labels. The next is load balancing. It distributes the traffic among pods for high availability. The next is help. So it's a Kubernetes package manager that simplifies the deploying, managing and upgrading the applications using pre-configured templates called charts. So in the Helm application, it's using for pre-configured templates, and also it easily simplifies the deploying, managing and upgrading applications. The key features are simplified deployment, customization, dependency management, version control. In the simplified deployment, it quickly deploys the applications like Nginx, Prometheus, etc. using the Helm charts. So using the Helm charts, we can deploy applications easily and fastly. The next is customization. It parameterizes the configuration to adapt to different environments. So for the different environments, we can configure the parameterized configuration. The next is dependency management. It automatically resolves and installs the application dependencies. The next is version control. It tracks the version of your application deployment for upgrade and rollbacks. The next is how AWS EKS work. So Elastic Kubernetes Services simplifies running Kubernetes cluster on AWS by managing the control plane while allowing you to focus on application deployment and scaling. So it's a running Kubernetes cluster on AWS for managing the control plane while allowing you to focus on the application deployment and scaling. So here we can see there is two nodes. One is control plane node, another one is worker node. In the control plane node, it's managed by AWS. The worker node is managed by customer account. So there is 3 different availability zones. So here we can see how control plane node and worker node is different and how it's managed by AWS and customer account. So control plane is AWS managed, so that's why it's automatically optimized the images and run the Elastic Kubernetes services. So it's managed by AWS and is responsible for handling the core management tasks of the Kubernetes clusters. Though the control plane includes this control plane node includes some key components like Kube API server, Kube scheduler, cloud controller manager and Kube controller manager. So the Kube API server handles the API request and coordinates the communication between Kubernetes components. In the Kube scheduler, it ensures the pods are placed on nodes with available network resources. The cloud controller manager interacts with the AWS infrastructure services. In the Kube controller manager manages the various Kubernetes controllers. So in the availability zones, since control plane is fully managed, AWS, it ensures the high availability across multiple availability zones. So that's why here we can use the different zones. So coming to the worker node, so EKS doesn't manage the worker node, it's a self-managed node. So Kubernetes, in this we can use self-managed. It's managed by customer and run the actual application workloads. Each worker node runs multiple pods and consists of components. So in the worker node, I have told you it's a self-managed. It can managed by customers. It runs the actual applications. So it runs multiple pods and consistence. So our worker process must be installed using some components like kubelet, kube proxy and container runtime. So kubelet responsible for managing pods and container on the node. In the kube proxy is managed the network communication for pods, and container runtime, its underlying software, it's responsible for running the containers such as Docker or container. So this is how it works. So there is a two-way, one is control plane and worker node. So control plane is managed by AWS, it's automatically works. The worker node is managed, it's a self-managed node. So go to the next slide. Use cases of AWS EKS. So the use cases are microservices architecture, hybrid code deployment, CI/CD pipelines and automation, edge computing, and high performance computing. Microservices architecture. So it ensures that any failure within one microservice doesn't bring down the entire application. It providing better resilience and fault tolerance, and also it's designed to handle the microservices architecture. So if in the when we are using the microservices in the architecture, so if in case the failure within the one microservice, but if in case it in the failure within the microservice, it doesn't affect bring down entire application. So it provide the better resilience and fault tolerance. And also it's designed to handle, Kubernetes is designed to handle the microservices architecture where each services run in its own containers and scale independence. The next is hybrid cloud deployment. So EKS ensures consistency in how Kubernetes clusters are deployed and managed across on-premises environment, and it's also integrated into hybrid cloud environments where workloads are split between on-premises and AWS. So when the workload is split to different cloud deployments on-premises or AWS also, when the workloads are split in the different environments, so it can be managed across the Kubernetes clusters are deployed and managed across on-premises environments. Next is CI/CD pipelines and automations. So CI/CD workflows can spin up multiple EKS clusters to test changes at scale, ensuring code quality before going to production, and can automate the deployment of new application versioning using the CI/CD pipeline. The next is edge computing. So EKS can help run application at the edge where data is processed closer to where it is generated. The reduces latency and increases the real-time decision making compute capabilities. So edge computing, it helps to reduce the latency and also it increases the real-time decision making capabilities. The next is high performance computing. So EKS supports compute optimized and GPU optimized instances, it making it perfect for computationally expensive workloads, and EKS can handle the workloads that require the high performance computing. So EKS Elastic Kubernetes services handle the workloads that workloads require the high performance, and also it's a optimized and compute optimized and GPU optimized instances. It's prefer for computationally expensive workloads. So these are all the use cases of the EKS. So the next is advantages of AWS EKS. So advantages, it's a fully managed Kubernetes services, highly availability and scalability, security, easy of use, cost effectiveness. Fully managed Kubernetes services. So AWS is managed the deployment, scaling and operations of Kubernetes clusters. So this eliminates the operational overhead for managing a Kubernetes cluster, it allowing you to focus on running your application. So it's fully managed means here it's kind deployment, scaling, updating, and also eliminate the operational overhead for managing the Kubernetes clusters. So it's only focus on your running your application. That's why it's fully managed. The next is high availability and scalability. EK is designed to be highly available and scalable. It runs Kubernetes control plane instance across multiple availability zones. It ensuring the resiliency and reduce the risk of downtime. EKS also allows you to scale your application horizontally and vertically as needed. So it also allows you can scale up application according to your need. The next is security. So it's designed with security in mind. It provides the several security features including VPC isolation, IAM roles in Kubernetes, services account, and AWS key management services integration for encrypting the services. The next is easy of use. EKS is easy to use even if you are new to Kubernetes. It provides a simple interface for deploying and managing your containerized application, and it integrates seamlessly with other AWS services. The next is cost effectiveness. So EKS is cost effective solution for running your containerized application. You only pay for the resources you use. and there are no upfront cost or long-term commitments. So it only pay what you use. So these are all the advantages of the AWS EKS. So the next is disadvantages of AWS EKS. So the disadvantages are complexity, cost, limited control over provisioned workloads, operational overhead, learning curve. So let's see one by one. Complexity. So setting up and managing the EKS cluster can be complex, especially for the beginners. So when we are beginners, so it's difficult to setting up and manage. The next is cost. So it's EKS can be more expensive than the self-managed solution because additional charges for the control plane. So worker node are self-managed, the control plane are AWS managed, right? So compared to the self-managed solution, it's more expensive because additional charges for the control plane. The next is limited control. You have less control over the control plane components, which may not suit highly customized use cases. The next is over-provisioned workloads. An over-provisioned deployment can waste cluster capacity and cause you to pay for more nodes that you need. The next is operational overhead. So you are still responsible for maintaining and operating the worker nodes in your cluster. Next is learning curve. So the learning curve can be steep and particularly for beginners. So for the beginners, it's particular. So these are all the disadvantages of the AWS Elastic Kubernetes services. So let's move to the demo and see how it works. So here we will see the demo part of the Elastic Kubernetes services. So before going to EKS, we need to install some Kubernetes that we needed. In the theory part, I have already told that that's what we need to install. So we need to install the EKSCTL. So go with this. So here we can see. So the installations occur in the two ways, that is one for Linux and another one for the Windows. So here I'm going with the Linux. Copy this command. Go to the Visual Studio. So take the WSL and paste it here. So take optional curve. Okay. Just so once again copy this one, go here and paste it. So run this command. So here we can see it's sudo mv. In the template in the user local pane it's installed. It unzip the file. So it's asking for password. So give the password. So here we can see the EKCTL Linux MR.g. Okay, so it's installed successfully. That's why it's asking password. So EKSCTL installation is completed. Now the next thing what we need to install is kubectl. So let's go to here. In Chrome, search for kubectl install. So here go with the install tools. So install and set up kubectl on Linux. So here we can see install the kubectl binary with kernel on Linux. Download the latest release with the command. So here copy this command. Go here, just paste it here. It will run. So it started this command. Yeah, okay, it's done. Then go to this. So here, scroll down. So here we can see. So to validate the binary, download the kubectl checksum file. Okay, copy this. So it started. So it's done, right? Then go back to this. Here, scroll down. So download the kubectl checksum file is done, right? The next thing is validate the kubectl binary against the checksum file. So we need to run this. So when the valid output is kubectl, okay, when we get this output, so the download the binary file is the right way, otherwise it shows some errors. So let's check. So copy this and run here. So here we can see the output kubectl, okay. So the download the binary checksum file is done. The next thing is so download the same version of the binary and checksum. Then we need to install the kubectl. So copy this command to install the kubectl. So sudo install -o root in the -g root in the kubectl user local bin kubectl. So let's enter this. It started installing. So installation is done, right? So let's go to this command. So to ensure the version you installed is up to date, to check the installation of kubectl is up to date or not, you can use this command, that is kubectl version client. So here we can see that is client version and customized version. So when the kubectl installation is done, we can get both the version, that is client and customized version. So this is how we need to install the kubectl and esctl. So these two are required to run the Kubernetes services. So the installation part is done. So the next thing is go to the AWS console. So go here. And this console search for EKS. So in the theory part, I have already explained Elastic Kubernetes services is a manage the control plane and it's fully managed Kubernetes cluster infrastructure. It's easy for use to Kubernetes AWS without needing to install and operate your own Kubernetes infrastructure. So here the EKS provides some documentation also. Here we can create in there two ways. The one is we can create the cluster, otherwise we can go with the documentation. So when we go with create cluster, so here we can see, so it's asking the quick configuration and custom configuration, and also it can ask for cluster configuration name, Kubernetes version, cluster IAM role, node IAM role, VPC. That's all the information. So we can go with the documentation. So you can interfere with the cluster also, or otherwise you can go with the documentation. It provides the user guide. here go with fix start. So here we can see, so you can read it, provide the prerequisite. So before you begin, ensure you are following prerequisite setup to use the Amazon EKS. So before we need to use the Amazon EKS, we need some prerequisites, that is set up the AWS CLI and configure the credential. So install EKSCTL and install the kubectl. So we are installing the EKSCTL and kubectl both, right? But we didn't set up the AWS CLI and configure credential. So it provide all the information to configure the cluster and create the ingress class and how to deploy. So it provide all the documentation. So before that, we need to set up the AWS CLI. So just go to the Visual Studio. Here we need the command as sudo AWS configure. Just enter this. So here we can see it's asking for the access key ID and the secret key ID. So in the IAM role, in the before ICS and IAM, I have shown that how to create the access key ID and the secret key ID. So just give the access key ID. So I've already created a user, right? So I'll give the same access key ID. So click for the secret key ID, access key. So and asking for the default region name AP South 1. So here we can check I am using the AP South 1 region. So just enter this and default output format none. Okay, just enter. So here we have set up the AWS configuration. So just here we can see. So we can set up the AWS CLI and configure the credentials. So here we can see we configure the credential also. The setup the AWS CLI and configure credential is done. Installation of the EKSCTL is also done and the kubectl installation is also done. The next step is, so the next is configure the cluster. In this section, you will create a cluster using the EKS outmove for dynamic node provision. To create a cluster config YAML file, then paste the following constraints in the replace the reason code. So we need to configure this cluster. We need to create a cluster configuration yam.file. So just copy this. Here we paste it. Yeah, that. So here we need to paste these commands. So here we can see the YAML configuration creating the EKS cluster using the EKSCTL. This for managing the Kubernetes cluster. So here we can see the API version EKSCTL IO v1 alpha 5. So this specifies the version of the EKSCTL API we are using in the case of the v1 alpha 5, and the EKSCTL.io, it indicates the YAML file intended for the EKSCTL. The kind we are is the cluster configuration. The kind of the resource that you are creating is a cluster config, which is the configuration file used to define the new EKS cluster. And the next is the metadata. The metadata section contains the key details about our cluster. So it contains the name of the cluster and the reason. So specify the AWS reason where your cluster will be created, like that. The next is auto mode configuration. This section defines the configuration related to the auto scaling in the cluster. Here we can enable the auto scaling configuration for the EKS cluster. When set the true, it allows the automatic scaling of the cluster. So when we are giving true, it automatically set the auto scaling cluster based on our demand. So this is the configuration cluster.yaml file. Just come out of this. So yeah, the cluster configuration file creation is done. The next thing is go back here. So here we can see now we are ready to create the cluster. So just copy this command. So here we can see EKSTL create cluster -f cluster configuration YAML. So once we are configure the cluster YAML file, we are ready to create the EKS cluster. So just copy this and go here, paste it here. So here we can see EKSTL create cluster configure.yaml, right? So EKSTL is a simple command line for creating and managing the EKS cluster on AWS. It create the EKSTL, which tells that you want to create a new resources in the EKS cluster. So the cluster indicates the resources you want to create in the Kubernetes, and the -f cluster configure.yaml. So the -f is a flag tells EKSTL use the specified files for the cluster configuration, and the configuration file is written in the YAML format and defines the desired setting for the EKS cluster, such as contain the EKS cluster name, reason, node settings, and Kubernetes versions and other parameters. So just enter this. So it showing an error, right? So loading config file cluster configure.yaml error, converting the YAML to JSON. YAML line 6 mapping the values are not allowed. Okay, just we need to check the cluster config.yaml. So white showing error means in the VM cluster here you can see here I'm not giving the reason, right? So that's why it's showing an error. I'm using the reason of AP Southwest. Okay, then all is right. Let's extend and create the again showing an error. Okay, I will check it. So here we can see it's now created. So why we it's showing an error while creating this, it's showing in the permission denied error. So if we need to give the attach the permission to the EKS service policy and EKS workload policies and Amazon EC2 full access. So here we can see, so once we attach all the permission to the EKS related, so it doesn't show any error or permission denied. So we can give the permission to attach the policies as Amazon EC2 container register and EC2 full access and EKS cluster policy, EKS service policy and workload policy. So these policies you have once attached, it can easily create the cluster. So here we can see it started creating the cluster. So here also we can see cluster config.yaml file is created. So wait until it complete the creation. So here we can see it's still in the progress. So let's go to the AWS console. Here you see the cloud formation in the stacks. Here we can see the EKSTL webkit starter cluster. It's create in the progresses. So the one we create in the Kubernetes services, it's created in the cloud formation stack. So once it's completed, it's showing the status as it's completed. So wait until it's still in the process. So let's go to the EKS, go for cluster. So refresh this. So here we can see in the cluster also it's in the state of creating. So once we are created in the Visual Studio using the create cluster command, so it will create the cloud in the cloud formation, it will create the stack. In the EKS it will create the cluster, that is webfix creating. So refresh this. So it's in the still it's in the creating status. So yeah, here we can see it's created the cluster. So once the cluster is created successfully, it in the states of active. So let's wait for few more minutes to create. So it's still in progress. Let's once again go and refresh this. We will check in the cloud formation stack. Refresh this. So it's still in the progress. So wait few more minutes. Yeah, here we can see the successfully created add-on. So just go to the stack. So building cluster stack is also done, deploying the stack. So we will go and check. So yeah, here we can see the cloud formation stack creation is completed. Let's go to the cluster. We will check the cluster is in active states or in creating states. Refresh this. So here we can see the cluster is in the active state. So go inside this cluster. Yeah, here we can see the information of cluster status is active, the cluster health issues, Kubernetes version, which version you are using, it's supported till the period, and the provider, and also it contains the overview details of all the Kubernetes services and resources. Here we can see the cluster web stick starting the AP South 1 region is ready. So the next step, so here we can see, so the create the Amazon EKS cluster is done, right? The next is create the ingress class. So why ingress class we need to create? So because for EKS auto mode we need to create the ingress class. So EKS auto mode handles the ingress resources. This step configures the load balancing capability of EKS auto mode, and also it creates the resources for your application. It uses this ingress class to automatically provision and manage the load balancers. That's why we need to create the ingress class. Copy this, go to Visual Studio, yeah, ingress class is created. So we need to copy this code, paste it here. Okay, we need to change this. Next is spec control, right? So we need to specify this. Okay, it's right. So I will explain the code. API version. It specify the API version of the ingress class resources in Kubernetes, and is the part of networking Kubernetes IO v1, and the kind field tells Kubernetes that resources being defined in the type of ingress class. And the next is metadata. So metadata, the name of the ingress class resources named application load balancer, which indicates that the class is associated with the ingress controller. And the next is annotations, or ALP means application load balancer. The next is annotations. So in the annotation, ingress class Kubernetes IO default class is true. This annotation marks the ingress class as the default for the cluster, and it specify the class in the ingress resources. The next is spec So they are using the controller EKS Amazon AWS.com application load balancer. So specify the ingress controller will be used to manage the ingress resources. So this is the code. So after creating ingress class, come back of this code. Right, ingress class is created, right? So the next thing is, so apply the ingress class to your cluster. So copy this, kubectl apply -f ingress class.yaml. So here mention sudo. So the kubectl, here we can see the kubectl, the Kubernetes command line tool that allows you to interact with the Kubernetes. The next is apply the command to create the resources, and the -f ingress class.yaml. So it specify the path to the file that define the Kubernetes resources. Let's run this. So it's asking for password. The error validating ingress class.yaml failed to download the open API. Move to the local host. Okay. So again, 1 second, go inside this. So again, we need to refuse. Okay, we need to solve this error. So I'm giving the permission to the IAM. Here we will see. So giving the EKS cluster policy, service policies. So let's check here. That is kubectl apply ingress class.yaml. Yeah, here we can see ingress class networking KTS IO ALB is created. So because I will recheck this again, that's why it's showing as is unchanged. Here I will show you ingress class.yaml, right? So here we can see you created, right? Okay, all right, then it's close, and we will check this. We will get this as ingress class network KTS IOS. LBS unchanged. So once first time you have applying, it shows as created. Otherwise, again you will check, it shows as unchanged. So after this, once the ingress file is created, so apply the ingress class to your cluster. So applying the ingress class to your cluster is successfully done. The next thing is, so deploy the 2048 game sample application. So the 2048 game as a sample application within the cluster. They provide the manifest, include the custom annotation for the application load balancer. This annotation integrate with and instruct the EKS to handle the incoming HTTP traffic. So it's handle the incoming HTTP traffic as the internet facing. To create the Kubernetes namespace called game 2048 with the save config flag. So we can use this command. You can see kubectl create the namespace of, so using the kubectl we can create the namespace of game 2048 in the configuration. So enter this. Yeah, here we can see the namespace game 2048 is created. So here we can see, you can get the output as name game 2048 is created. The next is we need to deploy the 2048 game sample application. So copy this, paste it in. Here we can see the kubectl apply -n game 2048. The kubectl is apply the game with the HTTP of GitHub connect with the ALB. AWS load balancing using the controller. So enter this. So here we can see the manifest the setup as a Kubernetes deployment service, the ingress for the game 2048 namespace, it creating the necessary resources to deploy and expose the game 2048 application within the cluster. So here we can see, we can get the namespace game 2048 configured and its deployment, the API apps deployment in the 2048 created and the service also created, and it's a ingress networking KTS is created. So we can get the same output. So after this, after the creating the game 2048 application within the cluster, the next thing is to run the following command to get the ingress resources. So we can get the ingress resources of game 2048 namespace. We can run this command, that is get the ingress. So it get the ingress file we have created. So here we can see, we can get the name of the ingress, the class is a AWS load balancer host, address of the ingress, and the port is 80 and the age is 45 seconds. So here we can see the same we can get. So you will need to wait the several minutes for the application to provision before you begin the following steps. So the next step is open the web browser and enter the address for the provision, set up the access web application for the example. So we can get this output, we can run this address. So when we run this address, we can get the web application of the game 2048 in the browser. So just copy this, K8s amazon.com. So go to the tab, just paste it here and run this. So okay, so it can reload this. Yeah, here we can see, we can get the output the same as and the quick start. So here we can see, right, the same output we will get using this address. So we are creating in this AP South one, right? That is the same one we are using. Here we can see. So using this address AP South one reason we can create this, that is 2048. The score passed, the join the numbers to get the 2048 title. So use your arrow key to move the tiles. When two tiles with the same number touch, the merge into one. So here, so this is how we can get the output using this address in the web application. So after this, kubectl will get ingress, right? Okay. So this is how we get the output. So then go back to the Visual Studio and using the command that has kubectl get pods -n game 2048. Enter this. So this command gets the details of the running status of our code. Here we can see. So name deployment 2048 and it is ready in the state of running. So it takes the timer 6 minutes 32 seconds. So this command shows the deployment status. So it's in the which state and it's the what time it takes. So this is how the kubectl work using the Kubernetes services. We can run the ingress.yaml file and create the cluster, and also we can get this output using this address. We can using this address we can run our commands. So and also it shows how to play, also it explains. So here we can see it's showing arrow keys, right? So click. So using the arrow key we can play this game like this. So this is how we play the game using the arrows key. So this is all about the Elastic Kubernetes services. So what is Elastic Kubernetes, how it works, and how to create the clusters, and also how to create the ingress files, and how to install EKSCTL and kubectl. So this is all about the Elastic Kubernetes services, and also using the documentation how to configure the cluster and create the classes and deploying the application. So this is all about the Kubernetes services. Thank you.